Good afternoon, everyone. I'm Josh Kulat, and I'm from the University of the Philippines. So now we're going to present our research project. Okay, we all use websites. We use our usernames and passwords to log into those websites. But the problem is, it is not secure. Even though we have HTTPS-enabled websites, it's definitely not secure. Username password scheme is very vulnerable to keylogger attacks, dictionary attacks, and password sniffing attacks. Also, this is the ordinary username password scheme. Even though you cannot see the password there, a keylogger can easily get the strokes you input to the computer, and hackers can easily obtain your passwords and steal your accounts. You don't want that, right? So, next, we see the available solutions companies have provided us. The first one is HTTPS. The next one are the commercially available security tokens. And the third one is biometrics. So let's check how secure, how low cost, and how reliable they are. So the first one is HTTPS. How secure is it? How does it make our how does it make our user experience more secure? HTTPS only secures the transfer of data from the source computer to the web server. It does not protect the user from keylogger attacks. So HTTPS has no effect on keylogger attacks or dictionary attacks. It only protects the transfer of data from one point to another. The next one are the commercially available security tokens. Given that, many companies have provided security tokens to enable two-factor authentication. This includes the RSA ID, which I think is very inconvenient because it comes at a price. And now you don't really see those kinds of technology being used in major websites such as Google Mail or Facebook logins. The third one is biometrics. Well, the problem with biometrics is that biometrics results are not 100% foolproof. Even lie detector tests fail, right? And biometrics require hardware, which you need to have in order for biometric systems to work. So now, we need something. We need to develop a system that helps us fight crime and try to protect our accounts online. That's why we present the SOL system. Why does the world need the SOL system? The SOL system is the secure online USB login system. It requires an ordinary USB flash drive as a storage, in addition to your password to secure your accounts. That's a two-factor authentication system which converts an ordinary flash drive like this one, which almost everybody has. It transformed this simple thing into a security token. Now that's amazing, right? So let's describe the parts of the SOL system. So the easiest part to describe is the website, which uses the SOL system, or SDK, which we provided. This is the trusted third party, which contains the public keys of the websites and the USB accounts. And this one is the USB program, which is a Java applet, signed Java applet, which can be accessed to log into your websites. And this is the files are encrypted and then hidden inside the images inside the USB flash drive. So now, the SOL system has evolved so much. We tried our best to make sure that there are no security breaches. And the one we submitted last January was version 2, which involved a cryptographic file system program inside the USB. It was cross-platform, yes. But the problem with this design is that it is inside the USB flash disk. It is easily seen by any user. It's there. That's the cryptographic file system is also there. So we wanted to make things a bit more secure, a bit harder for hackers. So that's why we transformed the cryptographic file system program into just a simple runnable jar file, and the integrity of the runnable jar file is checked by the signed Java applet. And now the hidden data is stored inside the PNG file. So how does the storage inside the PNG file work? We use steganographic techniques which store data inside the PNG file. The PNG file can store so much data. Even 300 by 300 pixel image can store a large amount of data. In our case, it was a lot more data which we can store inside it. We first encrypt the data to be stored in the PNG file and then hide it with steganography. Does that make sense? So now, the problem with version 3 is that the runnable jar file is still visible. We wanted something which is really invisible, yet secure. So now we transferred all the contents of the runnable jar file inside the signed Java applet. So the signed Java applet does everything for the user. It hides the data inside the PNG BMP file, and now we have the BMP file supported over here. And that's a 24-bit bitmap. Okay, so how does it work? The user simply mounts the USB flash disk into his computer. The user opens the website, which has the Sol plugin, the signed Java applet, and he selects the image inside the USB file. It's a USB flash disk where the data is encrypted. The password is typed, and then the password is used to decrypt the data stored inside the image. And the user is starting into the website. Pretty easy, right? Now, how to ensure that the data is transferred securely and the website recognizes and verifies that this is the correct USB account? First, the USB sends instructions to the website, but it first gets the public key from the trusted third party. The next step is that the website passes instructions, and of course it has the copy of the public key of the USB account from the trusted third party. So why do they need the public key? Because in RSA, each entity has a public key and a private key. The public key is used to encrypt the data to be transferred, and the public key encryption can only send so much data, and we transfer the shared key to the other side so symmetric cryptography can be used. So that's pretty clear. So that's a hybrid crypto system. So other security features include the use of universally unique IDs, one-time passwords so that old passwords cannot be used anymore, double password hashing, RSA signing and verification to ensure the integrity of the source, password salting. We use large size keys. These are very secure, and message UI checking to prevent man-in-the-middle attacks and other similar attacks. So this is the 3 parts of our system. So results. We managed to get the desired results. The system is very, very secure. The integrity, this is being checked every part of the process. And it is very portable. Just ensure that your computer has a Java runtime environment and the system works. It's very, very flexible because we have provided a software development kit for Java, Python, and PHP. And that's really hard to implement, but we are able to do it. And visibility, no Sol system files can be seen in a USB flash drive. And to make things more interesting, we can actually store it inside a cell phone because it's just an image file. So that's pretty cool, right? We always bring our cell phones, cellular phones everywhere, and we can use them to log in secretly. So for future work, we will provide more plugins so that it will be more natural for websites to use the Sol system and increase the number of files supported. We have actually tried MP3 files and JPEG files, but they can only store so much data, so we just stick to PNG files and 24-bit bitmap files. And support more languages such as Ruby, and so that we can support Ruby and Rails framework. So that would make it more easier for developers. But yes, the protocol is very easy to implement, and the Sol System SDK is very nice and easy to use. That's all. Thank you very much.